Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
We're going to be considering collagen that has a force acting on it of F, an original length, L naught, and a radius of the collagen of R. The Young's modulus for the collagen Y is 3.1 times 10 to the 6 Newton per meter squared. We're asked to assume that it obeys Hooke's law, and it wants us to find the spring constant for the collagen for part A. Okay, well, to do this, we're going to consider the fact that Hooke's law says that the force that's acting is equal to K times the change in the length, which would be delta L in this case. So we need to find delta L. We can find delta L from our relationship between the Young's modulus, L naught, the force, and the cross-sectional area of the collagen. So delta L here in this case is equal to F times L naught divided by Y times the cross-sectional area, which would be pi r squared. So if we go back to our Hooke's law, we find that K is equal to F over delta L. So now we're just simply going to replace delta L with our expression that we just found for delta L. The force values are the same, so they're going to be canceling. So we're left with Y times pi r squared over L naught. Therefore, we find that the spring constant K is equal to approximately 322, and the units would be newtons per meter, which we can box in as the solution for part A. Part B wants us to find the work that's involved. Well, the work here, W, by definition, is going to be 1/2 times the force times the change in length, delta L. Okay? So plugging these values in, we find that this is equal to 1.4 times 10 to the minus 6. And since the units here are work, the units would be joules, units of energy, which we can